Now let's look into the most important concept, that different types of coding or coding styles. As we have discussed earlier, we have talked about the same. There are two types of coding styles. The first one out of that, these are called basically explicit and the implicit interfaces. The first one is explicitly create figures and access and call methods on them. That's called object oriented style. O style. Okay, we explicitly create figures and also access, and on top of that figure and access, that's why we use fig as well as ax. So we'll create figures and axis, and we'll apply methods on top of that axis. That's called explicitly creating a figure. That's explicit method. Whereas we have another one is implicit method. So this one is simply rely on pyplot to implicitly create and manage the figures and axis and use pyplot functions for plotting. That's simple. So these are the two ways. One, you will be actively participating in doing lot of activities, whereas second one, you will be passive and pyplot will take over the action. Okay, let's look into the explicit one. Okay, the object oriented style. So coding styles, the first one is object oriented style. Now let's take one example for that so that it will be much clearer. It will be much clearer. So let me take x. X is equals to, we'll take an array. So this is our array, which is part of x-axis, and np dot linspace we have used in numpy, linspace, and inside that I'm gonna give values 0 to 2 and then 100. So this is our sample data, nothing much. This is sample data for x-axis. So now what I will do is I will create an one figure, so that even in the, basically we'll create a figure with this sample data. That's what we are going to do now. Okay, so now even in the object oriented style, we use pyplot.figure to create the figure. But what is the difference, that we'll see later. Okay, now let's create a figure. We'll say fig and then ax. See, that's what the definition says. I'll put it here. The explicitly creates figures and axis. Oh, see, we create a figure and we create an axis, and then we apply methods to that axis and figures is called object oriented style. Let's do that. So fig and then ax, these are the two variable names I'm providing. So now I will use as usual the same method. So I'll use subplots here. Subplots, and inside that I'll say fig size. So what's the fig size? I will have a 5 comma 2.7. That's the fig size I'm gonna go with. Fig size 5 comma 2.7. And layout as usual. We did it before. It's constrained. Constrained. Correct? Constrained. Okay. So that's it. This is what our fig and the x. Now we have to start applying methods, or we have to start calling methods to these fig and ax objects. You got an empty one, correct? So now let's apply a first method. Our first method, we will plot some data on the axis. That's what is our first activity. Let's plot some data on the axis, not axis. So let me do that. I'll take ax.ax. That's what our axis object. And then the method I'm going to call is plot method. So anyway, we have a sample data that is x on x-axis. And after that also I'm using x even for the y-axis. Then I'll say label. I'm directly attaching a label. Label is linear. Linear. Clear? And execute it. And here is that. You got a plot which is linear. So now on x-axis, if you want to see what data we have generated, let me show you that also. I'll print x array. You see that? This is our data from 0 point till 2 point, and I have made this into 100 fractions. 100 fractions. These are all proper. These are all called improper fractions. Okay, total 100 improper. From 0 to 2 we made 100 improper fractions, and we put them in x-axis as well as y-axis. You see, x is from 0 to 2 and y is also from 0 to 2, and x is the one first we have mentioned, and second one is x again. This is for the y-axis. This data is for y-axis, and then label we have gone with the linear, and here is the picture. So now one method we have called, and similarly we'll call few more methods. Okay, so this time I'm gonna I'm gonna convert this into different types. So what we did, we called a linear. So I'll create one more plot that is a linear, that's a quadratic one. So ax dot a plot, I'll use a plot, and x comma, and now I just want to plot y is equals to x square. So now let me add the values for the y-axis, the values that to be plotted on y-axis. So I'm going to go with x square. So, and the label is quadratic. The label is quadratic. And then that's it. Let me attach the. So this is plotting. Let's plot a quadratic equation or curve on the same axis. Okay, and this goes like this: y is equals to x square. So all fine. Now let me execute it, and here is that. Brilliant. The orange one. You got it? This is our linear equation, and this one is quadratic equation. So one more, I'm gonna plot it. So this time I'm gonna plot. Let's plot more data on the axis. So some more this time. So this time I'm gonna plot cubic equation. Cubic equation on the axis. Clear? So now this goes like this: y is equals to x cube, and ax dot plot x and cube, label, and it's cubic, and execute it, and here is that. So you got a straight line, a linear equation, and you have a y is equals to x square, a quadratic equation, and then cubic equation. All three. Orange is quadratic and other one is cubic. So now what we will do is we will add a labels to the axis. We will add labels to this graph. So let's add an x label to the axis. Add an X label to the axis. So for that I have to use the AX dot, as we have discussed before, it's set and then underscore X label. That's it, pretty simple. And inside that you have to mention the value. So the value would be here, I'll say directly X label. Simple. And let me execute it. We should see, and here is the X label. And similarly, let us add a Y label also. Add a Y label to the axis. So AX dot set underscore, this time it's Y label, let's say Y label. That's it. So X label and Y label has been added. Let's check. You can see that X label has been added and Y label has been added. And finally, let's add a title. Let's add title. So let us add a title to the axis. Okay, so now AX dot title. So the title would be simple. A title would be algebraic or algebra equations. And okay, something is wrong with that. So I have to use so I should not use this single quote. Let me use uh, okay, so I'm using the wrong method. The right method is we have to go with the set title. And here is that. So you got the algebra equations, that's the title, and you got X label and Y label. And the final one, we will add a legend. Let's add a legend. So AX dot legend and execute it, and here is that the final form of graph is absolutely ready. So here we got all the components, by and large all the components that whatever is required. So let me show it to you. Yeah, this is coding style and plotting functions, and here is the figure. Just a minute. Yeah, I'm gonna show. So we got the axis labels, and we have x-axis label, y-axis label, and then we have the title, we have the legend. So almost all done. So but how did we do that? We did it using application of methods to the axis and figure object. So we have done by applying to the figure object. You see that axis object ax, and we called different methods. We called different methods and applied to the ax axis, and then we have built we have built we have built this graph actively. So that's the reason we call this as explicit way of doing, or object oriented style.